In this video, I'm going to be looking at acids and bases and the beginning introduction to the theory of acids and bases. So let's get started. The first thing you need to know about acids and bases is what is an acid and what is a base. And there's a variety of ways that you can categorize acids and bases. And the two main ways I'm going to talk about are the Arrhenius theory and the Brønsted-Lowry theory. The Brønsted-Lowry theory is a bit more modern, and it's actually what we use in schools and what you'll be learning. And the Arrhenius one is also an important one to be aware of. An acid or a base, according to Arrhenius, is anything that is related to the transfer of H plus as well as OH minus. So Arrhenius described an acid as a substance that released a H plus in solution. So anything with a H plus would be considered a acid. A base, according to Arrhenius, was anything that released a OH minus in solution. So anything with a OH minus would be considered a base. And let's have a look at an example. If I wanted to describe how HCl is an acid, then the way Arrhenius would describe this would be to show a single ionization of H plus Cl minus. And as you can see, because this single H plus formed a H plus, so as you can see, because this HCl formed a H plus, you would say that HCl is an acid according to Arrhenius' theory of acids and bases. Now let's have a look at an example of a base. So we'll have a look at potassium hydroxide. According to Arrhenius, you can split these into cations and anions, and because you are releasing a OH minus, that's what makes it an acid or a base. In this case, H plus makes it an acid, and in this case, OH minus makes it a base. Now let's have a look at the Brønsted-Lowry theory. Why is there two different ways to explain what an acid and a base is? Well, the main fundamental problem of Arrhenius is he wasn't able to describe why some things acted as a base or acted as an acid despite not having a H plus or an OH minus. And an example is ammonia. Now, if you were to guess whether this is an acid or a base, you could guess it's an acid because it has a H atom in there. However, ammonia is actually basic, and Arrhenius had no way to describe why this was basic despite there being no H minus, no OH minuses. So the Brønsted-Lowry theory is a little bit different in that an acid is anything that donates a proton, and another way of saying proton is H plus. That's another way of saying a proton. And a base is anything that will accept a proton or gain a proton. And a proton is H plus. So let's have a look at those two same examples that I used before. We'll take HCl and OH minus. HCl, I can show it accepts a proton. And the way I can show it is by doing it in a hydrolysis equation. A hydrolysis equation is pretty much adding water to anything, because you're hydrolyzing it by adding water. Now, if I wanted to show how this acts as an acid, I can show that it's donating its proton. Because we know HCl is made up of H plus and Cl minus, we know it's going to donate, i.e. lose the H plus, and it's going to go to the H2O. So I'll explain exactly what this is. In this equation, the HCl has lost a proton. As you can see, it went from HCl to Cl minus. There is no more H plus here. And the H2O it went from H2O to H3O plus. So it actually gained a proton. It actually gained a proton. So because HCl has lost a proton and becomes Cl minus, you would say that HCl is in fact an acid. And because the water gained a H plus, it gained a proton, you would say that H2O is a base. Now, another thing you need to know is we know that HCl and OH2O are acid and base respectively. However, we can also identify what Cl minus and H3O plus are. Because HCl is an acid and we just made Cl minus, we can categorize Cl minus as what's known as a conjugate base. The reason why we say it's a conjugate base is because Cl minus, it has the ability to regain that H plus. And because it has that ability to regain a H plus or accept a proton, that's what a base does. And because it started off with HCl, that's where the name conjugate comes from. Conjugate comes from where it started. It started at the HCl, and that's how they linked. They're conjugates. And the reason why it's a base is because this is the acid, and this if it wanted to become neutral again, would have to gain a H plus. So the acid and the conjugate base are opposite relationships. So what do you reckon we would call this then? If this here H2O was a base, what would we call this hydronium ion? We would call it a conjugate acid. And that's how Brønsted-Lowry explains whether something is an acid or something is a base. We'll have a look at the example that Arrhenius couldn't prove, and we'll show that with ammonia. NH3 plus water. We always show it with a hydrolysis equation in Brønsted-Lowry theory of acids and bases. Now, in this example, I'm going to put a reversible arrow, reversible equilibrium arrow, because the ionization of ammonia is actually reversible. It is in equilibrium, unlike HCl. And I'm going to write the equation as if it was a base. So let's work through it like this. I claimed that NH3 was basic, and Arrhenius couldn't explain why. Well, this is why. If a base is anything that gains a proton, then we might assume that NH3 will become NH4 plus, because it has gained an H plus, and we know that anything that gains a H plus has to be a base. So we know that H has been gained, so it becomes NH4 plus. And if this here is the base, we know this here is the acid. The water has to be the acid, hence the name acid-base reactions. So if this here is the acid, we know it has to lose a H plus. That means it just becomes OH minus. And that's how it works always with water. If water is an acid, it will always become OH minus. If it's a base, it will always become hydronium. So once again, this here is a base because it gained a proton. That means this is a base. And water in this example is an acid because it has lost a proton. And that's how you can identify whether something is an acid or a base. And once again, we know if this is the base, ammonium or NH4 plus has to be the conjugate acid, because it has to be the opposite of the ammonia. And hydroxide has to be the conjugate base. So that's how you identify if something is an acid or a base according to the Brønsted-Lowry theory. If you enjoyed this video, please make sure to like and subscribe, and leave a comment below on what videos I should make next, and if you have any queries regarding these videos. Thank you.